Hey guys, this is Mr. Palacios coming to you. Today we're going to practice graphing these quadratic equations. So we're converting back to our original formula, f of x equals ax squared plus bx plus c. So when you're factoring these things, think about two things. That the x squared really equals x times x, and I'm going to put them into a different sort of formula, and that'll make sense in a little bit. But just know that we're going to set up our equation like this: f of x equals parentheses x minus blank, end parentheses, new parentheses, x minus blank. Those x's might end up turning into pluses at some point, but in this blank we're going to be putting a number, like in this one down in this example right here. But back up top really quickly. So our a is basically we're doing x squared equals x times x. And then for b and c, you need to think about two things. Two numbers that are added or subtracted that equal b. So in this example right here, we want two numbers that when you add them together equal 2. Now that could be almost anything. So the really important part is the c, which is that they need to be added or subtracted to equal b, and they need to multiply to equal c. And that kind of cuts things down, because only a couple things you multiply together to get these numbers. So today, for this example, f of x equals x squared plus 2x minus 3. Just think about what two numbers you can multiply together and get negative 3. And I'm including this minus sign in front of the 3 as the sign of the 3. So this is a negative 3 that we're dealing with. So really only two numbers come to mind. It's either negative 1 and 3, I guess it's four numbers here. Negative 1 and 3 can multiply to become negative 3, or 1 and negative 3. Now if I think about which one of those combinations equals 2, then I am stuck with my first option. Because if I do 1 minus 3, that's going to give me negative 2. If I do negative 1 times 3, negative 1 plus 3, that's going to give me positive 2. And right here I have a positive 2x. Okay, so start thinking of these signs as connected to the number. So we got a positive 2 right here and a negative 3. Okay, so obviously this second group 2 does not equal 1 plus negative 3 or 1 minus 3, but 2 does equal negative 1 plus 3. So those are going to be the factors that I put into my equation. So I told you, write out your equations like this: f of x equals parentheses x minus blank, close parentheses, new parentheses, x minus blank, and then we're going to add things or we're going to add things to that function and to this factor of this function. So in this example, we're going to incorporate these two numbers into it. So f of x equals, first parentheses, x minus 1, okay, and then second parentheses, x plus 3. So we're just adding the little line right here to make it a plus, and then a 3 right here. We're adding a 1 right here. We don't need to change that sign because it's a minus 1. Now the cool thing about factoring our functions is that the moment we factor, we find out our two x-intercepts. That's going to be the line, or I'm sorry, the point at which our graph crosses the x-axis. So in this case, we have 2 points where it's going to cross the x-axis, where x is going to equal a certain number and y is going to equal 0. All right, so that's how we find our x-axes, and that's through factoring, which makes these things pretty simple. Now, the midway point of the x-coordinate, so when you find this out, you see we have negative 3 right here, and I have 1 right here, okay? These are 1, 2, 3, 4 positions on the number line on the x-axis away from each other. The midway point is 2 over from the 1 and 2 over from the negative 3, and that puts me at negative 1. My vertex, the x-coordinate of my vertex, is going to be negative 1. Okay, that's the midway point. And you know, when we're graphing these functions, it's a parabola that is coming up like this. And you know that that midway point is going to be where the vertex is. Now the only thing we need to figure out is where's the y coordinate. What is the y coordinate of the vertex? Well, to do that, all we need to do is to plug in this negative 1 into our function. And so I have negative 1 squared plus 2 times negative 1 minus 3. And when I multiply that all out, that gives me 1 minus 2 minus 3. Okay, 1 minus 2 is negative 1. Minus 3 is negative 4. And so the y-coordinate of my vertex is going to be negative 4. And I wrote that out here. My vertex is negative 1, negative 4. I didn't put the point down here, but if I did, it would belong right here. Negative 1, negative 4. That's the vertex of my graph, of my function. Okay, and then the other thing that we want to look at, so we figured out how to find the x-intercepts, where the graph is going to, where the function is going to cross the x-axis. We found out what the vertex is. We practiced that as well. The last thing we need to know is what is the y-intercept? Where does the graph cross the y-intercept, the y-axis? And so in order to do that, we set everything to 0. X is equal to 0. And when we do that, we find that our answer is C. Okay, so if this is 0 and this is 0, all we're left with is that C value. Okay, the A constant is gone, the B constant is gone. All we're left is that C constant. And so our y-intercept, where it's going to cross the y-axis, is actually at negative 3. Okay, so all in all, we've learned how to figure out where the vertex is. We've figured out how to move our function in the different parts of our coordinate plane. And today we reviewed how to find our x-intercepts, our y-intercepts, and our vertex point. Just another way to do it. Good graphing. Please answer those 5 questions. Talk to you guys later. Peace.